All right, so standard form of a quadratic function for the less than essential question is what key features can you determine about a quadratic function from an equation in standard form? At the end of this lesson, you can write and graph quadratic functions in standard form. So yes, there is some graphing, not as much as we did in Unit 1, but there is still quite a bit of graphing involved. Most of it, though, you don't necessarily have to graph the function. Helpful, but not necessary. All right, so example 1, conceptual understanding, find the vertex of a quadratic function in standard form. So how can you find the vertex of a quadratic function written in standard form? So the standard form looks like ax squared plus bx plus c. So what is the x coordinate of the vertex of f of x equals ax squared plus bx plus c? Well, the standard form of a quadratic function is that the ax squared plus bx plus c, where a, b, and c are real numbers and a cannot equal 0. We can use the vertex form to derive standard form, okay, which we did last lesson. Y equals a times x minus h squared plus k, okay, where I multiplied the ax minus h out. So I get x squared minus 2xh plus h squared, which then simplifies to this. Y equals ax squared minus 2ahx plus ah squared plus k. The equation y equals ax squared minus 2ahx plus ah squared plus k is a quadratic function in standard form with a equal to a, b equal to negative 2ah, and c equal to ah squared plus k. The vertex of a quadratic function is hk. So to determine the x coordinate of the vertex, I can solve b equals negative 2ah for h. So I get negative 2 or negative b over 2a. Since a is the x coordinate of the vertex, you can use this value to find the y value k of the vertex. So how can you find the vertex of a quadratic function written in standard form? So what's the vertex of the function f of x equals x squared minus 6x plus 10? So identify the coefficients a, b, and c. A is 1, b is negative 6, c is 10. I solve for h, the x coordinate of the vertex. So h is negative b over 2a. So b is negative 6, a is 1, so negative 6 divided by 2 times 1, which gives me 3. Then I substitute that value of h into the equation for x to find k, the y coordinate of the vertex. So f of 3 equals 3 squared minus 6 times 3 plus 10. So that's 9 minus 18 plus 10 equals 1. So the vertex of the function is hk equals 3, 1. All right, so let's try it out. What's the vertex of the graph of the function f of x equals x squared minus 8x plus 5? So I want to identify the coefficients. So a is 1, b is negative 8, c is 5. I want to solve for h. So h is negative b over 2a, which is negative 8 over 2 times 1, which equals 8 over 2, which simplifies to 4. So my x value is 4. I then substitute that value in for my equation. So 4 squared is 16. 8 times 4 is 32 plus 5. So f of 4 equals negative 16, negative 11. So my vertex is 4, negative 11. All right, example 2, graph a quadratic function in standard form. How can you use key features to graph f of x equals x squared minus 4x plus 8? So again, I identify a, b, and c. So a is equal to 1, b is equal to negative 4, and c equals 8. I find the vertex and the axis of symmetry of the quadratic function. So the vertex, I find h, which is 2. Substitute that back in to find y, which is 4. So the vertex is 2, 4, and the axis of symmetry is x equals 2. I find the y-intercept of the quadratic function. So the y-intercept occurs at f of 0 equals 0 squared minus 4 times 0 plus 8, so at 8. If the y-intercept is the same as the vertex, choose a different point. I want to find a point symmetric to the y-intercept across the x-axis of symmetry. Since 0, 8 is a point on the parabola, 2 units to the left of the axis of symmetry, x equals 2, and then 4, 8 will be a point on the parabola, 2 units to the right of the axis of symmetry. I can then sketch the graph. Okay, so once you have 3 points associated with the quadratic function, you can sketch the parabola based on your knowledge of its general shape. So I want to use the key features to graph the function f of x equals x squared minus 6x minus 1. Drag the points on the graph to change the position or the shape. Let me go ahead and open this then. So the first thing that I want to do is I want to identify a equals 1, b equals negative 6, c equals negative 1, h equals negative b over 2a is negative 6, 2 times 1. 6 over 2, which equals 3. Then I substitute that back in. So 3 squared minus 6 times 3 minus 1. So f of 3 equals 3 squared is 9. 6 times 3 is 18. Which gives me negative 10. So my vertex is 3, negative 10. My axis of symmetry is x equals 3. And I find the y-intercept, so f of 0 equals 0 squared minus 6 times 0 minus 1. So that's negative 1. So that gives me a point 0, negative 1. We know it's a parabola. And since 0, negative 1 is the point on the parabola, 1 unit down, it's going to be, this is going to be 10 units down, 3 units to the right. And it's going to pass through the point 0, negative 1. And the axis of symmetry is 3. So I can go ahead and start graphing this. Okay, so here's 3. Move it over here first. Okay, so that's where my axis of symmetry is. I know it's 10 units down. Okay, so I'm going to move it 10 units down. I know it passes through the point 0, -1. 0. Let me do it the area. Right there. So that's going to be 3, -10. There we go. It's really hard to like make sure it's perfect, or as perfect as possible. There you go. Okay. So it was 3 down, 3 over 10 down, passes through 0, -1, and then it also passes through 6, -1. Check our answer. So 3, 0, -1. Example number 3, interpret the graph of a quadratic function. So the graph of the function f of x equals -10x squared plus 700x minus 6,000 shows the profit a company earns for selling headphones at different prices. What is the maximum profit the company can expect to earn? Okay, so here's my parabola. All right, so the first thing I want to do is formulate. The x-axis shows the selling price and the y-axis shows the profit. The maximum y value of the profit function occurs at the vertex of its parabola. So I want to find the vertex. So in order to do that, I use the function to find the x and y coordinates of the vertex. So I find the x coordinate of the vertex, which is -b over 2a. So in my original problem, A is -10, B is 700, C is -6,000. So B is 700 over 2 times -10, which gives me 35 when it's simplified. And then I substitute that back in to find, for my X value, to find my Y value, which is 6,250. So the vertex is at 35, 6,250. So the selling price of $35 per item gives the maximum profit of 6,250. That's what it represents, this function. Okay, so if I sell something for more, I'm making less profit. If I find a good, nice, medium ground, that's going to be my highest profit levels. Okay, so let's go ahead and try it. A water balloon was thrown from a window. The height of the water balloon over time can be modeled by the function y equals -16x squared plus 160x plus 50. What was the maximum height of the water balloon after it was thrown? So as we can see, my vertex is going to be around here somewhere, but I need to actually find what it is. So A is -16, B is 160, and C is 50. So I want to find H, which is -e over 2a. So that's -160 over 2 times -16 equals -160 over 32. 160 divided by 32 is 5. So my X value is 5. So I substitute that back in. 5 squared is 25. So f of 5 equals negative 400 plus 800 plus 50. Okay. So negative 400 plus 800 plus 50 is 450. So what's the maximum height of the water balloon after it was thrown? So the maximum height is 450 feet. Because that's my vertex was 450. So after 5 seconds, times 5 seconds, it's going to be a maximum of 450 feet. So for example 4, I want to write the equation of a parabola given 3 points. So what's the equation of a parabola that passes through the points negative 2, 32, 1, 5, and 3, 17? Okay. So I want to write 3 equations by substituting the given x and y values into the standard form of a parabola equation. So y equals ax squared plus bx plus c. So for negative 2, 32, I get 32 equals a times negative 2 squared plus b times negative 2 plus c. For 1, 5, I get 5 equals 1a plus 1b plus c. For 3, 17, I get 17 equals 9a plus 3b plus c. Okay, so here is my set of equations. I can set up a matrix just like we did in Unit 1 and find the row reduced echelon form. So the solution to the system is a equals 3, b equals negative 6, and c equals 8. I then substitute those numbers back in, and then I can confirm that the graph of the equation passes through those 3 points. So I'm going to do the same thing for this. So I substitute them in. 12 equals a times 2 squared plus 8 times 2 plus c, which is negative 12 equals 4a plus 2b plus c. I have negative 15 equals a minus b plus c. And then my last one is negative 90 equals 4 squared is negative 4 squared is 16a minus 4b plus c. So those are my 3 equations, which I can then change to a matrix. I'm going to reduce row echelon form A. So A is negative 4, B is 5, C is negative 6. A is negative 4, B equals 5, C equals negative 6. So when I write my equation, y equals negative 4x squared plus 5x minus 6. All right, example 5, use quadratic regression. Esteban is training for the discus throw. His coach recorded the horizontal distance and height of one of Esteban's discus throws. The points show the horizontal distance the discus traveled in meters and the height of the discus in meters.
Esteban is training for the discus throw. His coach recorded the horizontal distance and height of one of Esteban's discus throws. The points show the horizontal distance the discus traveled in meters and the height of the discus in meters. Use quadratic regression to predict the height of the discus when it has traveled 15 meters from Esteban. The data shows the discus only rising, but when the discus starts to fall to the ground, it will make a shape that looks like a parabola. The model should be a quadratic function. You can use graphing technology to perform quadratic regression with the data. Enter the coordinates of all of the points into the table. Then find the regression features in the calculator's menu. Since a quadratic model is needed, choose quadratic regression. You can write the regression model using the values from the calculator. You take A, B, and C and put them in a quadratic equation. X in your model stands for the horizontal distance of the discus from Esteban. Since you want to predict the height where the horizontal distance is 15 meters, substitute 15 for the horizontal distance in the model. Then simplify. Based on this model, when the discus is 15 meters away from Esteban, it will be at a height of approximately 10.5 meters.
All right, so standard form of a quadratic function is y equals ax squared plus bx plus c. Okay. So key features, I can find the vertex, x coordinate of the vertex, h equals negative b over 2a. I can substitute for h for x and solve for y to find the y coordinate of the vertex. The axis of symmetry is x equals negative b over 2a, and the x-intercept is 0, comma c. Or that's the y-intercept, sorry. Y-intercept 0, comma c. I can, of course, graph all of these. So 0c is the y-intercept. My axis of symmetry is the x equals negative b over 2a. And, of course, my actual function is y equals ax squared plus bx plus c.